So weight of the object is acting downward, which cause a clockwise movement. Force cause anti-clockwise. The moment due to the force was 24 Newton meter, and the moment due to the weight is 27 Newton meter. The moment due to the force of 40 Newton was acting in anti-clockwise direction, and the moment due to the weight of an object was in clockwise direction. So this object will not topple. So the question is, the ground is rough so that the slab does not slide. State and explain what happened to slab as the horizontal force gradually increases. So if I increase this force gradually, like it is 40, I made it 50, then I made like gradually here, like 40, 41, 42, and so on. So if we increase this force, the moment due to the force will increase also, and at certain force, the slab will topple. Figure 3.2 shows a uniform rod P and Q supported at the center and held in a horizontal position. The length of PQ is 1 meter. And if they say it's a uniform, so if something is uniform, where the weight will act? The weight will act at the center. So there is a weight of the rod also, which is acting at the center, but it is also acting on the pivot. So when the force is acting on the pivot, it does not cause any rotation or does not cause any turning effect. So this weight will not cause any kind of rotation or any turning effect. A force of 12 Newton, act at a distance of 0.3 from the support. Which direction this force is causing a moment or turning effect? So this is causing an anti-clockwise rotation. The spring has a tendency to pull the rod. So which direction spring will apply or cause a moment? It will try to cause a moment in clockwise direction. And if it is balanced, because whenever you're solving a question related to moment, you assume that it is balanced. So the clockwise moment, we need a force exerted on PQ by the spring. So if we need a force exerted by PQ on the spring, what we'll assume the anti-clockwise moment and the clockwise moments are same. So anti-clockwise moment equal to clockwise moment. The anti-clockwise force is 12 multiplied by distance from the pivot, it's 0.3. So 12 multiplied by 0.3 equals clockwise moment, the force of a spring, example I'm saying F, and the distance from the pivot, the pivot is exactly at the center. So if total length is 1, so this distance will be 0.5. So this will be 0.5. And 0.5 is multiplied, other side it will divide. So it will be 12 multiplied by 0.3 divided by 0.5. What's the answer? 12 into 0.3 was 3.6, and 3.6 divided by 0.5 is equals to 7.2. So the force which is exerted by the spring is equals to 7.2 Newton. So whenever you are solving a question related to a moment, you will always consider the clockwise moment is equals to anti-clockwise moment. In the question they mention, figure 3.2 shows a uniform rod supported at the center, held horizontal. So held horizontal means it is balanced. So if it is balanced, the clockwise moment should be equal to anti-clockwise moment. So what is the anti-clockwise moment? That's equal to 12 is the force and distance from the pivot is 0.3. The clockwise moment is the force of the spring multiplied by distance from the pivot. If total length is 1, so half of the length is 0.5. So it will be F multiplied by 0.5. The anti-clockwise moment is equals to clockwise moment because it is balance or horizontal position. So 12 multiplied by 0.3 is equals to force of a spring multiplied by 0.5 or the distance from the pivot. So you will get that force, and that force is equals to 7.2 newtons. The weight, it's a uniform object. The weight is also acting at the center, but weight will not cause any moment. Why the weight does not cause any moment or turning effect? Because it is acting on the pivot. So there's no perpendicular distance between the force and the pivot. That's why its moment is also 0. So force is there, but it does not cause any moment or turning effect. So why it is not necessary to know the weight? Why we don't need weight of an object or weight of the beam or rod? Because weight is acting on the pivot, so it does not cause any rotation. That's why we don't need weight. No, not balance, you will mention. The weight is acting on the pivot, so the weight does not cause any rotation. If weight was not exactly at the center or weight was not acting on the pivot, like example, weight was either towards right or left. So in that case, the weight will also cause a moment clockwise and spring will cause a clockwise and the 12 Newton will cause an anti-clockwise. Another question. Figure 3.1 shows a device used for compressing crushed materials. If you want to compress the crushed material, we can use this device. The lever arm rotate about the hinge, this edge hinge. So it's rotating about. So what is the pivot here? H is a pivot. A force of 20 Newton act downward. So force is acting downward. Which direction this force will try to cause a moment? So this will be anti-clockwise. A force F of the crushed material on the plunger. This is a plunger. So which direction this force will try to cause a moment? The force F will cause a clockwise moment. Use the clockwise and anti-clockwise moment, calculate the upward force. So whenever you're solving a question related to clockwise and anti-clockwise, your assumption should be that the clockwise moment and anti-clockwise moments are same. So if anti-clockwise moment and clockwise moments are same, so the force which you applied, it's 20 Newton. But what is the distance from the pivot? H is the pivot. What is the total distance from the pivot? Distance from the pivot. The pivot is point H. So from start till the center, this point is 380 and remaining is 120. So what is the total distance? That's equal to 500. It will be 380 plus 120. That's equal to 500 millimeter. What is the clockwise moment? The force F is there. Which direction this force F is trying to cause a moment? It's causing a clockwise, so force multiply. What distance I should take to solve to get the moment? What is this distance? So that's equal to 120. So 120. Then solve 20 multiplied by 500 divided by 120. What's the answer? 20 times 150 divided by 120. Sorry, 20 times 500 divided by 120. 83.3. So the force which is exerted here is equal to 83.3. Always write your answer in 3 significant figure. And because it's a force, so it will be Newton. Is it clear? Figure 3.1 shows a diagram with an arm. Whenever you're solving a question related to a moment, if they don't mention, you will always assume that the clockwise moment is equals to anti-clockwise moment. That's always your assumption. Because without this assumption, you cannot solve a question of moment. If they ask, identify whether the object is in equilibrium, that time you don't consider clockwise moment and anti-clockwise moments are equal. That time you have to find clockwise and then find anti-clockwise and then compare them. But if in the question you don't have to say about equilibrium anything, you will always assume that the clockwise moment and anti-clockwise moments are same. So in this question, a force of 20 Newton, the 20 Newton force is a weight of a forearm. This 20 Newton is a weight of the forearm acting at the center of mass, acting at its center of the mass, and force F is a force by the muscles. So this is a force of the muscles. Elbow, point P in the elbow is a pivot. So this is a pivot that they might mention. Which direction this 20 Newton will cause a moment or a turning effect? What is the direction of the moment or the turning effect of 20 Newton force? So this will cause a clockwise. And which direction this 120 Newton force will cause a moment? A force of 120 also. You can see both forces are in the same direction and same side of the pivot. So that will also cause a clockwise moment. So both forces are causing a clockwise. Which direction force by the muscle is causing a moment? That's anti-clockwise. And we assume for this question again, the anti-clockwise moment is equals to clockwise. So anti-clockwise movement, that's a force multiplied by distance from the pivot. So what is the distance from the pivot? So distance from the pivot is 2. So force multiplied by 2 equal the clockwise moment. This force is 20 and distance from the pivot is 15. So 20 multiplied by 15 plus there is also another moment clockwise, which is 120 multiplied by distance from the pivot is 33. So 120 multiplied by 33. Because both moments are in the same direction, that's why I add the moment due to 20 Newton force and the moment due to 120 Newton force. So F multiplied by 20 multiplied by 2 is equals to 20 multiplied by 15, 300, and 120 multiplied by 33. So 3,960. So 3,960. So 3,960 plus 300. So 4,260. So force F is multiplied, other side it will divide. So F is equals to 4,260 divided by 2. The force exerted by the muscle is 2,130. Is it clear? So the force exerted by the muscle is 2,130. So 2,130 Newton is up, a 20 Newton is down, and 120 Newton is also down. Now, if the next part, we need a force exerted by the pivot to make it balance. A force act on the forearm at point P. Calculate this force and state the direction. Because to balance it, as you know, in terms of force only you need. So I'm drawing the same again, but only forces. I don't need distance when I'm using a force. So 2,130 Newton is the force of the muscle. 20 Newton is the weight of the forearm. And 120 Newton is the weight So to balance it, which direction the pivot should apply force, upward or downward? To make it balance, to make the forces balance, which direction the pivot should apply force? 2,130 is up. So to make it balance, the pivot should apply a downward force. So the direction of the force of the pivot should be downward. And how much it should apply a force? So how much force? Because upward is 2,130 and 120 is downward. So how much force the pivot should apply? So 2130 is up. And the downward force is the force of the pivot plus 20 plus 120. When you solve 20 plus 120, move other side. So it will be 1990. So the answer for the next part is 2130 minus 20 minus 120. That will give 1990 Newton. And which direction this force is exerted? This direction was down. So to make it balance, the pivot should apply a force in downward direction. A student is investigating the extension of a spring. Figure 5.1 shows a spring with and without a load. Which distance that shows the extension of a spring when load is added? Which distance we should take? To calculate the extension. Extension means increase in length. Which distance we should measure to get the extension? Extension means increase in length. A, B, C, or D? C is the right answer. Why C is the right answer? You can check here in the question. No, actually, we have to just mention which one we have to take. If you check, C is from the bottom of the hook till the bottom of the hook. So we take 2 points. Why not B? Because B is the distance from top of the hook to the bottom of the hook. So that's wrong. So when we are measuring an extension, if I want to measure the extension, say a spring is there, I measure the lower part of a spring first time, and then I attach a load. So to get the extension or increase in length, I should measure from the same point, the distance between the same points. But here in B, first we measure the distance from the top, and then we are measuring a distance from the bottom. That's why B is not a correct answer. C is the right answer. The graph shows the student results. State whether the graph show that the load and extension are directly proportional. This is related to the last class. Are they directly proportional? Yes or no? So in a statement, you will say yes. And reason or justification, because it is a straight line
that passes from the origin.
So straight line is passing through the origin. it shows that they are directly proportional.